All right. Now, I'm going to take my, see, I can do this on my graphic calculator. Can you? Are you guys practicing storing the values? Because if you're not, you're gonna be in big trouble because rounding errors are going to occur and points are coming off.
Points have already
So if
come
you
off.
get off by like one decimal as long as
Yes. Well, if you're off in the third decimal place by 0.001, I'll just take off 1. But basically, this is how the test is gonna go. Where's my chalk? Where's my chalk? Probably on my desk. This is how the test is going to go. You're going to have approximately 12 to 14 problems. You're going to be worth 6 points each. You're going to get 1 point for the correct, not 1 point. You're going to get 3 points for the correct integral, and then 3 points if you punch it in on your calculator. Once you get the integral wrong already, if your integral is wrong, that's minus 6. So you have to write down the correct integral. So let's go over, what do we need to go over, first of all? 1 and 2, they're pretty much, that was the last test that we took, except now you get to use your calculator. Well, do you guys know how to store stuff on your calculator?
Yes.
No.
2 BC!
Oh, this thing, yeah.
Okay, number 2. We got y equal ln x, y equal x squared minus 3x. Now, when you punch these in on your calculator, this is going to be y1 and y2, right?
Yes.
Okay, so here we go. So, if you were to graph this on your calculator, I don't need a calculator to graph this. You got natural log x. Yeah. And then y equal x squared minus 3 is the parabola opening upward. It looks like that, right? Now, to figure out the area, what you're going to do is you're going to make the rectangles. Yeah.
Are you going to give us graphs or are we going to draw the graphs?
You have a graphing calculator, right?
Oh, no, I'm just not.
Yeah, so I don't need to give you the graph because you have the calculator, you can draw it, yeah. So, how do you find the length of the rectangle? Top minus bottom. Now, if you want to write out natural log x minus quantity x squared minus 3x, you better put the parentheses there. Or, would you rather just go y1 minus y2? See, if you define it on your paper, then you don't have to write it again, you know? And then you can punch it in on your calculator also as y1 minus y2. You know what I mean?
Oh, we have to put it on our paper for it to be.
Yeah, it's going to be on your paper. Multiplied by the infinitesimal width. Now that's going to be worth 1 point every single time. You don't write a dx or a dy, that's going to be a minus 1 automatic on every problem. And then you add it up from, since you're doing the integral in terms of x, you go from the x coordinate here to the x coordinate there. So, how do you find these intersection points? Okay, wait, how do you turn on this calculator?
Stop it.
AC is not.
Menu, graph. I'm not used to this calculator. So I draw the graph, see, it looks exactly like I drew it there. And then I go G-solve, intersection. So the first intersection point here is x equals 0.37427933128. Y equals negative 0.98275293345. Now, when you use a number in another computation, you have to use all the decimal places. Now, but when you write it on your paper for the AP exam, you only have to write 0.374. Or, a better way to do it is, since I'm going to use this number 4 times, right, because number 2, we got A, B, C, D. I'm going to be using this number 4 times in the problem. I'm going to store this in A, and then I'll just put A there. So you don't have to write out all of this, you know what I'm talking about? But you have to show it on your paper, scan it.
We have to write the decimal out and then say.
No, you can just put 0.374 stored in A, but when you do the computation on your calculator, you got to use all the decimal places. That's why if you store it, your calculator automatically plugs it in with all the decimal places already. So how do you store this into A? Well, once your calculator computes the point of intersection, this number is now stored in X. This number is now stored in Y. But once you calculate something else, it's going to calculate another X and it's going to wipe out this one. So that's why we need to store it into A. So how do you do that? you go back to the menu, go to Run Matrix, punch in X. Where's the X button? Press X, enter. This number just pops up. And then store. This, you see the right arrow? Store, so right arrow, into alpha A. Enter. Now, anytime you punch in A on your calculator will plug this number in with all its decimal places. So but if you don't like this, if you want to keep writing it all out every time, you certainly can if you want.
Can you get to the Y1
Okay, now how do I find this point of intersection? We gotta go back to the graph. So menu, graph. Okay, you gotta draw it again. Oh, that's why I like the other calculator better for some things. G-sub intersection. So that's the first one, and then I right arrow to get the second point. So this point of intersection is x equal 3.3606838876. Y equals 1.2121444488. So since I'm doing the integral in terms of x, I want to store this x value into b so that I can just put b there. So now I got to go back to the run matrix. So menu, run matrix. Boom. Then I punch in x. Here's x. Boom. That number pops out. I'm going to store it into alpha b. Boom. There you go. Now it's stored for all four of those problems. I don't have to keep that in. So if you define these things on your paper, then there. That's the first 3 points for part A. You had 3 points right there. You know what I'm talking about? Because I know this is what some of you are going to do on Tuesday. You're going to go like this. Natural log x minus x squared minus 3x. I know already. That's going to lead to that's a minus 6 pretty much. You know why? Because you need this parentheses there. It's this minus that.
Where did you put the parentheses? Yeah, that.
Then you get the 3 points. Now can you punch it in and calculate?
No.
Another 3 points. Now the other question is, Mr. Park, how do you get y1 and y2 on your calculator so you don't have to punch in the functions over and over again? Well, okay, when you compute an integral, remember how to do that? You press options, calculus, the integral. Now, basically when you have an integral, you have to fill in these boxes, right?
Right.
Like that. So what you want to put here is y1 minus y2. That's what you want to punch in. So left parentheses. Now, how do you get the y? You press varsity. It's not varsity, it's variables. Variables, graph, and then you get the y there. Press the y, and then press 1. That's y1. Minus variables, graph, y2, right parentheses. And then right arrow, then the thing comes over here, you go alpha A, right arrow, then you go over there, you go alpha B. So A, B, right arrow, press execute, and the thing just spits out the answer. 5.552. Easy. And so when you do all the other problems, all you have to do now, everything is all defined, it's easy to punch in. Hop.
Wait, so do we have to write the x values that we're storing on the paper?
Well, yeah, so you have to write at least the 3 decimal places.
Oh, okay.
So you don't have to write all the decimal places, it's just that when you use it, you gotta use all. So you can just do this, 0.374, I'm gonna store it into A. That's fine, as long as you show at least 3 decimal places. But you gotta use all of them. Okay, so this is part A. Which is the one we needed to do, Lee? C. Find the volume of the just when you revolve it around x equals 4. So here's x equals 4. This is just like yesterday's test. If this rectangle gets revolved about this line, you're gonna get a shell. Why you're not drawing the picture? That's why! Label the point x, y, just like we normally do with the shell. So what's the formula for the shell? 2 pi radius height dx. And I'm going to add them all up from A to B. Every single problem is going to be from A to B, right?
Yes.
Okay, so first of all, what is the radius right there?
4 minus
Well,
x.
okay, very good. 4 minus x. And then the height of the shell is simply the length of the rectangle, which is y1 minus y2. Punch that in. Now, I don't care how you punch it in. Like, if you rather just go, I just go punch in natural log x minus quantity x squared minus 3x, that's perfectly fine too. I rather just go y1 and y2. In fact, you know what you can do is, you already have this written down, right, Prisman? All you gotta do is edit it. Just put the 2 pi and the 4 minus x in front of it. You guys know how to grab a previous entry, right? Just use the up arrow, and then you can edit it. You don't have to punch it in all over again. You can just use it over and over and over. Harada.
Can you store the y1 and the or the y2?
No, it is. Once you graphed it on your calculator, this is y1 and that's y2.
Yeah, but like instead of like having to go like vars, graph, stuff like that, can you store it into one of like the letters?
Oh, I don't know. I don't think so. I don't think so.
Okay.
I think the letters have to be like constant.
Yeah, the letters are for numbers.
Oh, okay.
Numbers. Okay, and then is there another one we need to go over?
4.
No, I mean in number 2. In number 2.
Might as well do D.
Yeah, do
Yeah,
the.
might as well.
Okay, so y equals 2 is up here, right? Here's y equal 2. So here's the rectangle. When this rectangle goes around the line, you gonna get one washer. What's the formula for the washer? Pi big R squared minus small r squared dx. Add them all up from A to D, right? So here we go. What is the big radius? The big radius goes from the center to the outer edge. How do you find this? Top minus bottom. 2 minus the parabola. So 2 minus y2 then, right? And then the inner radius goes from the center to the inner edge. How do I find this distance? Top minus bottom. 2 minus the natural log graph. So 2 minus y1. And since everything's defined on your paper, that's good. And then I'll just punch it in. But on the test, we still have people going bottom minus top. What is that? Or they're going left minus right. That's a pretty big error because that's going to cause your integral to become negative. But on the AP exam, I would say most of the time they're just going to ask you to write the integral. So if you go bottom minus top, then that's a whole point taken away already. That's 11% of the problem gone. Okay, what are we doing next?
Oh, negative.
You literally just said it. Keep on.
What, you went bottom minus top?
Yeah.
Oh.
Wait, but I didn't know that it was y.
Yeah, but then you get the negative.
But then you're not going to be computing it on the AP exam. You're going to just write the integral.
Oh yeah, but for the test you just get the negative, make it positive, and put a negative sign in front.
Yeah, that's what some people tried last time and it didn't really work.
Oh really?
Yeah. Because maybe that's not Prislin, maybe that's not the error, that's why. Maybe it's some other error, that's why. You know what I'm talking about? Okay, do we need to go to number 3?
Yes.
Okay, average value. Oh no! What was the formula? I'm going to tell you, average value is going to come up 2, 3, 4 times on the AP exam. What's the formula for average value again? 1 over b minus a integral from a to b of f of x dx. Does that look familiar? And what does the average value give you? Like if you have a graph, okay, here's a and b. If you have a continuous graph from a to b, this integral, when multiplied by 1 over b minus a, gives you the average of all the y coordinates on the graph. This graph is made up of an infinite number of points. How do you take the average of all the y values? You do that integral. It gives you the average of all the y coordinates. So like on the AP exam, I think they had like, okay, okay, so they'll give you the equation of the graph, then the graph, and they'll tell you, okay, so this is the graph of all the temperatures in Minnetonka, Minnesota from January 1st to December 31st. What was the average temperature from January 1st to December 31st? What do you do?
1 over b.
1 over 365, integral from 0 to 365 of whatever function they give you. It'll give you the average of all the temperatures. In fact, from this day forward, whenever you see the word average, whatever problem you're doing, that means average value. Okay? So look how easy this problem is. 1 over b minus a, so 5 minus -2, integral from -2 to 5 of whatever the function is, e to the negative x squared dx. You got 3 points. You want the other 3 points, just punch it in on your calculator. It just gives you the average of all the y values. Fujimoto.
On the AP exam, are they gonna give us the formulas?
Yeah, they have to, otherwise what are you going to integrate, right?
Some tests you're gonna give us the formulas. Yes.
Yeah, but sometimes you might have to like think. Wait till we come to a later problem. Just wait till we come to a later problem. Yes, I'll give you a formula, but you might have to do something to that formula.
Oh.
Like for example, what if I gave you the position equation? What if I ask you to find the average velocity?
Oh. Oh.
Then if you know position, how do you get velocity?
Derivative.
You gotta take the derivative. And, so you know what I mean? Yeah, I kind of gave you the formula, but you gotta take the derivative to put it here, right?
Yeah.
So yeah, some kind of formula has to be given. And by the way, when you do your homework, you cannot just put the answer now. You have to have an integral and an answer. Because I gave you all the answers. Some clown in the other class wants to call. He's just writing all the answers. Duh! If that's the case, why not just copy and paste it then?
We have to find the local max. Oh wait, no, we have to find out.
Now, this is a really, number 4 is a really good problem. I like this problem. I would not be surprised if I give you the same problem on the test.
Okay,
So what? No, not the exact same one.
that would be great, because I
No.
don't even understand this.
No, I'll just change the function though, but they're like the same concept. So basically you have a cubic polynomial, it looks like this. A particle is traveling at 5 units per second on this curve, right, constant speed. How many seconds does it take to travel from the local maximum to the local minimum? How long is it going to take you to travel this distance? What's the first thing I need to find?
Derivative.
I've got to find that distance. How do you find the distance along the curve from here to here? Length of curve, that's right. So what is the length of curve formula? The integral from x1 to x2, square root of 1 plus dy dx, quantity squared dx. This was on the last test. Not yesterday's test, but the last test, right? Length of curve. So to find the length of curve, what do you have to do? You have to take the derivative, and then you gotta square it. Well, here's the function. How do you take the derivative? Easy. This is the polynomial. What's the derivative of this? 3x squared minus 6x minus 9 plus 0, of course. There you go, easy. And now you gotta integrate it from, I gotta know the x coordinate there and the x coordinate
1,
there.
2, 3.
How do you know?
Yeah.
Now, this is, I never even thought students would do this, but this is what some people in the other class did, the one who actually did the problem. They said, Mr. Park, I just graphed it, and I G-solve max, G-solve min. Oh, that's how you guys, you use calculus! I didn't think students would do that.
What do you mean?
How do you find maxes? We learned this 4 months ago. If you have any function, how do you find the maxes and mins of that function? You take the derivative and you make a number line. Exactly, so what's the derivative?
But this is a calculator test. Why do we do that?
No, it's not. Look how easy this is. X squared minus 2.
Yeah, but the other one you just hit a 2
Factor
button.
out a x plus 1. Make a number line. -1 and 3. Plus minus plus. That means y is increasing, decreasing, increasing. So the max occurs there and the min occurs there.
Why bother if you can calculator?
Because on the test, AP test, they're gonna ask you compute the maximum and minimum, justify your answer. If you did it on your calculator, that's not justification. They want, no, they're testing you to see if you know calculus, and you use
So,
calculus.
do you want us to?
Yes, this is what I want. I didn't even dream students would do that.
Look how smart we are.
You took the number line.
Work smarter, not harder.
Anyway, -1.
Bill Gates said he employs.
Okay, whatever.
I'm lazy.
Anyway, on the test, for this particular test, if you want to do that, you can.
Yes.
But in the future, and if you want to do it on multiple choice, but see, on the multiple choice, they're going to design the problem so that you can't do that. So, you know what I'm talking about? They want you to use calculus to solve problems. Anyway, you write this on your paper, you get 3 points. You want the other 3 points, can you punch it in correctly? Now, the other class told me they got the answer, but Mr. Park, that's not the answer on the bottom. That's because you didn't answer the question. The question is, how long is it going to take to travel from there to there? Not find the distance to travel. This is the distance to travel. So how do you find how long it took? Well, rate times time equals distance. We are trying to find time. So time is distance over rate. So this is the distance that you traveled, right? What is your rate? 5. So you gotta divide that answer by 5.
Wait, how do we know that our, oh wait, no, I okay.
Yeah, because it says the rate is 5. That's why. Yeah. Right? The problem wasn't that bad. You guys can do that.
5.
So I'm pretty sure if I change the problem, you could do it. What if I change the 5 to a 4? No. How about like, no, we can do that, Mr. Parker.
Now freezes over.
5F.
Okay, number 5.
Just do all 5.
Yeah, I'm gonna do all of 5.
Good choice.
Okay, so I give you the velocity, which is t cubed minus 4t.
Yeah, so are we allowed to, wait, when you designed this problem, did you think we'd do that, or did you think we'd just look up the, like?
No, I thought I thought this would be a
But
good
why?
review
Because
to
we
find
can just
maximum.
tell from the graph whether it's decreasing or increasing.
Yeah, but how do you know what that exact point is?
You can just.
G-solve. Okay, but let me ask you this. Okay, what if this is on the no calculator part?
Oh,
Oh,
well then we have.
Take that out.
Yeah, exactly.
No problem.
But look at that. Look, I designed it so that it factors super nicely. And if I give you this problem on Tuesday's test, I'll make it so that it's factorable unless you take the derivative wrong. Right? Anyway, what's the first problem? For what values is the velocity decreasing? Okay, here, look. How do you tell if a function is increasing or decreasing? You take its derivative and you make a number line, right?
Okay.
Like over here, here's the function. When is it increasing or decreasing? I take the derivative and I made a number line. So it's increasing, decreasing, and increasing,
You
right?
have to do that.
So, when is the velocity decreasing? How do you tell when a function, it doesn't matter what function it is, here's a function. How do you tell when this function is decreasing? When its derivative is negative. So what you do is, here's the velocity, you take the derivative of this. Now it turns out the derivative of this is acceleration, but it really doesn't matter, it's just the derivative of it. Like that, right? That's the derivative. You graph it on your calculator, you're gonna see something like that. You're gonna see something like that. Now I don't know what these numbers are, I'll just call it A and B. So when is the velocity decreasing? When its derivative is negative. Well, look at this graph. When is the derivative negative? When is the graph below the x-axis? Between A and B, whatever those numbers are. But you can G-solve that on your calculator, right?
Yeah.
Okay. Part B, now this is a totally different question. When is the speed increasing or decreasing? Now we did many of these problems 3 months ago, but you probably forgot, yeah? How do you determine if the speed is increasing or decreasing? You gotta make a number line for the velocity and the acceleration.
Oh, this is
Remember
like
that? So, the speed is increasing when the velocity and acceleration have the same sign. The velocity is decreasing, I mean, not the speed is decreasing when the velocity and acceleration have opposite signs. So what you have to do is you have to make number lines for both of them. Okay, so for the acceleration, our number line looks like this. Plus, minus, plus, right? Above, below, above. But then now you also got to make a number line for the velocity. So this is the velocity. You got to graph this on your calculator and make a number line for it too. So I don't know what it's going to come out. I'm just making up something, okay? Why don't we call this C, D, and E? And let's say it's minus, plus, minus, plus. That's what it is. Okay. So what's the question? When is the speed increasing? That means when does the velocity and acceleration have the same sign? Well, look at your number lines. If you lined it up correctly, what? Between C and A, because they're both positive. Where else? Between D and B, because they're both negative. So when they have the same sign, the speed is increasing. When they have opposite sign, the speed is decreasing. Surely you guys remember that, right? But then you gotta make these number lines. That's what you gotta do. Okay, C. C is easy. How do you find the displacement of the particle from 0 to 4? This is probably, you know what? Average value is not the easiest on the test. This is the easiest problem on the test. How do you find displacement? You just integrate the velocity from 0 to 4. We did this on the last test. That's it. Write the integral. In fact, if you have this punched in as y1 on your calculator, you can just put y1 there. You don't have to type that all in, and boom, you get your answer.
0 to 4.
0 to 4. You integrate the velocity from 0 to 4. That's the displacement. D, on the other hand, is the total distance traveled. What's the difference between the two integrals?
Absolute value.
Absolute value of the velocity. Everybody knows how to get absolute value signs on your calculator?
Yes.
Okay, good. 'Cause there's going to be a difference between the two now. There's a big difference. And the other class, who was it? Matsukawa telling me, what if I mixed it up? Well, that would be a -6 and a -6. That's a -12. Because you got to get the right integral, right, to get any points. Uh-oh.
Why
And
would you
then-
mix that up?
Because he's Matsukawa, that's why.
I just feel like that's.
And then finally, F. How many people actually did F? Sakamaki? Okay. That's fine. Now,
Wait, have it to E.
oh,
yeah.
oh, find the average. Okay, no, what did I tell you? The word average from this day forward means average value. So they're asking, what is the average value of the velocity? What's the formula for average value? 1 over b minus a, integral from a to b of, what are we trying to find? The average velocity. So you put the velocity dt here. Oh, so Mr. Park, the answer for E is simply the answer for C divided by 4. Yeah, because look, wasn't that the answer for part C? Yeah. So again, remember, whenever you see the word average, it means average value. So you use the average value formula. Pretty easy, huh? And then part F. Now, the reason why I put this problem on is because the last 10 years, the AP, they have lots of problems like this. Okay? They're going to give you some function. Okay, I'm going to give you this. In fact, it's going to come up on the second worksheet again. It's going to be on the test as well. And almost every AP exam, you're going to have to do this like 3-4 times. They're going to give you some function, and they're going to say, okay, what is the antiderivative of velocity? No, antiderivative. Remember, it goes like this: position, velocity, and acceleration, right? If you go this direction, you take derivatives, but if you go that direction, you go antiderivative.
Position.
Yeah, position, or so the antiderivative of velocity is position. So they'll give you something like, in this problem, x of 0 is equal to 2. What is x of 5 equal to? So in other words, they're going to give you a function, and they want you to figure out something about its antiderivative. So in this particular problem, can I take the antiderivative of the velocity equation? Yeah, but the ones they're going to give you, the one I'm going to give you on the test, you're not going to be able to find the antiderivative. So you got to learn how to do it. Because I'll give you something like, here, I'll give you something like this, cosine of t squared plus 1. You cannot find the antiderivative. Yeah, you don't. Because you can't find the antiderivative of it. There is no antiderivative. You cannot.
What do you do?
So what you do is, no matter what I give you, we're going to use the fundamental theorem of calculus part 2. Watch what I do. I'm going to integrate the velocity from, just put v there. We don't need all that. Just put v. What are my limits of integration? This is the hard part. 0 to 5. Now, why did I pick 0 and 5? Because one of them I know, the other one I'm trying to find. Now, how do I compute the integral from 0 to 5? What do I do? How does the fundamental theorem of calculus part 2 work? You take the antiderivative. No. Okay, let's go back and review. Look. How do you compute the integral of x squared dx from 0 to 3? How do you do
Plug
that?
in the 3.
No, first you take the antiderivative of that. 1/3 x cubed, and then you plug in the top number, you plug in the bottom number, and subtract, right? That's the fundamental theorem of calculus part 2. So I'm going to do the same thing. What's the antiderivative of the velocity? Antiderivative. Position. Plug in the top number, plug in the bottom number, and subtract. This is called the fundamental theorem of calculus part 2. But that takes so long to say. So the past 10 years, we just gave it a name. This technique that we're using here, the name we gave it is code red.
Why?
Because it's easy to say. Plus, 10 years ago, I don't know, just at that time, I said we need a name. I don't want to keep saying fundamental theorem of calculus part 2. So we just said code red because at the time I was watching A Few Good Men. You guys ever saw that movie?
No.
Did you order the code red?
What is code red?
Code red is when they kind of ambushed the guy, taught him a lesson.
Okay.
Anyway, so from this day forward, when I say code red, that means the fundamental theorem of calculus part 2. I want to keep saying that. So when do you use it though? When they give you a function and then you have to find out something about its antiderivative, but you cannot find the antiderivative. That's when you use code red. That's what this is. So how does this work, Mr. Park? Well, didn't I give you the velocity equation? Here's the velocity equation.
Yeah.
Can't you compute any integral on your calculator? Yeah, you just punch this in on your calculator. I don't know what you're going to get. So whatever it says. And then we know this is equal to 2. So how do I find what this is?
You put the.
Add 2 to both sides, right? So the answer is simply this plus 2.
Oh.
It's like this, look. A equal B plus C. I know what this is because I can compute it on my calculator. I know what that is because it says so on the paper. How do I find B? A minus C. You just move it over to the other side. This is easy. Okay, try it, and then you're going to have another problem just like it on tonight's worksheet. Okay, number 6. Do we really need to go over number 6?
Number 7.
Okay, let's do it. If I give, this was on the last test. If I give you a rate, this is the rate at which water is flowing out of a pipe. I think I used the same problem last time. Actually, this should have been a T. That's a mistake. Nobody caught that, so you don't get bonus. It's supposed to have been T, not X.
Oh, because our
Because T stands for time, that's why it is. Anyway, this is the rate at which water is flowing out of a pipe. So if this is the rate at which water is flowing out of a pipe, how do you figure out how much water came out of the pipe during the first 10 minutes? You just do an integral from 0 to 10. Boom, write that down on your paper, punch it in, that's the easiest 6 points you're going to get. Because look at the units, dimensional analysis. What is the rate measured in? Gallons, this is in gallons per minute. Time, well for some of you don't even write the DT, so that's what you don't know, is minutes. What is gallons per minute times minute? Gallons. That's how many gallons flowed out of the pipe. That's why, like over here, how do you find the displacement and the total distance traveled? Velocity is meters per second. Time is measured in seconds. The seconds cancel out, you get meters. You get that's a distance. It all makes dimensional sense. Anyway, all you gotta do is punch that in on your calculator. That's so easy. Okay, number 7. You guys remember how to do that? We did this on the last test too.
No.
Okay, let's do it, number 7. We got a very short-term memory, yeah? Y equal x e to the negative x. Mr. Park, I don't know what that graph looks like. Well, you have a calculator, sister.
My goodness, it was a sister, not a brother.
I don't know, I'm pretty sure it looks something like that. And y equals 0, and x equals 3, right there. This is the region in question. I'm going to cut that into 2 equal pieces. Remember we did that on the last test? Oh gosh. So I'm going to cut it in, with a vertical line, cut it into 2 equal areas. I don't know what that value of k is, that's what we got to find. Does that look familiar?
Yup.
So, how did we do this last time? What did we do?
Solve the original.
Find the original area. So how do you find area? Top minus bottom. So that's this minus 0, multiplied by the width. Add them all up from 0 to 3. Punch this in on your calculator, and you're going to get, I don't know what the number is. I would suggest store it into A. because we're gonna have to use that in another computation. Okay, so if this vertical line cuts it into two equal parts, then shouldn't the integral from 0 to k of top minus bottom be equal to a over 2? Whatever the area is, it's half of it, right? And then you solve that equation. Okay, now, how do you solve this equation? This is what the other class had problems with. How do you solve this equation?
You have to do tabular.
Yeah, you gotta compute the antiderivative of that, and that's tabular. So let's do it. X, 1, 0. E to the negative x, negative e to the negative, plus, minus. So what's the antiderivative of that? It's gonna be negative x, e to the negative x, minus e to the negative x from 0 to k. That has to equal to half the area. Okay, so how do I compute this part? Plug in the top number. Negative k, e to the negative k, minus e to the negative k, minus, plug in the bottom number, 0 minus 1. That equals a over 2. How do you solve any equation on your calculator? Like, this is the first thing you learned in pre-calculus or algebra 2. You can solve any equation on your calculator. What do? We did this at the beginning of the year.
Make
Everybody
one
knew how to
side 0.
make one side 0 and graph it out. So on your calculator, this is what you punch in on your calculator. y1 equals a negative x e to the, because you gotta use x's, that's why. Minus e to the negative x minus, you want to just put plus 1 then? Because it's
Yeah.
distributed. And then minus a over 2. You gotta make one side 0, that's why. Punch this in on your calculator. Graph it, wherever it crosses the x-axis, that's your answer. That's your answer. Does that sound familiar? You can solve any equation on your calculator. Simply just make one side 0, graph it, and wherever it crosses the x-axis, that's it. Okay, finally, last problem. Oh boy. How come this is taking longer than yesterday? We still gotta go over the test. Number 8. I don't think we're gonna finish. Because we need to go over something. Because if you cannot do disc shells and washers, this test is going to be a nightmare. Okay, find the length of it. What's the formula for length of a curve again? Square root of 1 plus the derivative squared dx. And since we're doing, look, I gave you the limits of integration, 0 to 3. All you have to do is whatever function I give you, I'm going to give you some function. All you got to be able to do is take the derivative and put it right there. We already did that problem once, didn't we? Oh, you erased it. Yeah, that's BC stuff right there. Okay, so how do I take the derivative of this function right here? We did it so many times on the homework. Not magic. It's called the Fundamental Theorem of Calculus, Part 1. The higher up in mathematics and science you get, the more and more functions look like integrals. Does that sound familiar?
Yes.
So the first thing you do is you make sure the lower limit is a constant, which it is. And how do you apply the fundamental theorem of calculus part 1 tells you how to take the derivative of a function that's defined as an integral. And it's really easy. Remember what you do? You take this top thing, plug it in for t. So what do you get? Square root of 1 plus x to the 4. And then the most important part. You gotta multiply that by the derivative of that, which is 2x. If you do not multiply by the derivative of that, that's going to be a minus 6, because you don't have the right integral. This is called the Fundamental Theorem of Calculus Part 1. Does it even sound familiar? How many times in this class have I drawn this? You plug it in, and it times it by the derivative of that. Only about 20. Okay, and then I'm assuming we can punch all of these things in on the calculator. I don't know, that might be a bad assumption. Okay, let me pass back the test. Gotta turn off this camera first.
Ooh-wee.
Ooh-wee!